Well, in section 1, part 1, we looked at various ways to solve quadratic equations. Specifically, we looked at solving by doing square roots of both sides of the equation. We solved by factoring, we solved by doing the quadratic formula, and we solved by completing the square. Well, now this is going to be more of an application lesson. It's really two parts. We're going to look at some problems involving how to find the discriminant of a quadratic equation, and then we're going to look at some real-life problems that can be modeled by quadratic equations and how those can be solved. But first, let's do a quick review of the discriminant. Here's the formula to find the discriminant. If you just take the part of the quadratic formula that's underneath the radical, then you will have the discriminant. So here it is. I've given it for you in green, b squared minus 4ac. So let's first of all understand how to find it. Remember, this number in front of x squared is considered a, and this number in front of x is b, and then the number in front of this constant at the end is c. So finding the discriminant, I will do negative 3 squared, which is 9, minus 4 times a times c, and I'm going to do 9 minus, and this is negative 56, and when we put that together we get 65. So here's the deal about the discriminant. It's really all about its sign. Notice that it's positive 65. For a positive discriminant, you are going to have two real number solutions. And taking that one step further, as we look ahead to graphing, two real number solutions when it comes to the graph means we're going to have two x-intercepts. In other words, our graph of this quadratic equation, when we do get to graphing, of course it's going to be a parabola, and it's going to be a parabola that crosses the x-axis in two different places. All right, so that's how you're going to interpret the positive answer for discriminant. So what do we do for the negative? If you end up with a negative discriminant, then you're going to have no real number solutions. You're going to have two imaginary solutions. Sorry. Or we might sometimes use the word complex number solutions. Complex numbers involve the imaginary number I. But I'm just going to state it as two imaginary solutions, meaning the number underneath the radical is a negative, and when we try to do the square root of a negative number, that means it's got to be an imaginary number. So when we have two imaginary solutions, we have no x-intercepts. This particular parabola, if it did have a negative discriminant when it's graphed, would never cross the x-axis. All right, well, the only possibility, the third possibility, is that the discriminant is 0. So if the discriminant is 0, that means we have one real number solution. And we therefore have one x-intercept. When the parabola is graphed, if the discriminant is 0, the only way to have one x-intercept is if it's the vertex that sits on the x-axis. So it would be, this would be an example. It would be a parabola where the vertex is the only part of the parabola that's touching the x-axis. Okay, so I gave you the three possibilities. Positive discriminant, find the discriminant, and then your directions want you to basically interpret that solution. Whatever that number is will lead you to saying you have two real number solutions, two x-intercepts, negative, this is how you would state it, or if the discriminant happens to be 0, you would state it in this way. All right, so now that leads us to some modeling problems, or also known as word problems. So the question here for 91, and I believe you're going to be doing 92, which is very similar. How many right triangles have a hypotenuse that measures 2x plus 3 meters and legs that are the given meters? So I guess a picture probably would help a little bit. So let me just draw a right triangle, and we're told that the hypotenuse is 2x plus 3. The hypotenuse is always across from the right angle. And then we have two legs. We'll just call this one 2x minus 5 and this one x plus 7. So the way that we solve for missing parts of a right triangle, the most common way, most popular way, is by using the Pythagorean theorem. And there it is in case you forgot it. So remember, C always represents the hypotenuse. So I'm just going to take the three sides of the triangle as they're labeled and substitute in for C, A, and B. C being the hypotenuse, so this is 2x plus 3 quantity squared. Really doesn't matter which of these is A and which is B. I'll just say that A is 2x minus 5 quantity squared, and that means B is going to be x plus 7. Okay, so we got three binomials that need to be expanded, and I showed you this earlier. Instead of writing 2x plus 3 down twice multiplied by itself using FOIL, I'm just going to do this three-step mental math process, which means it goes like this. We look at the first term in the parentheses and square it. So if I raise 2x to the second power, I get 4x squared. To get the middle term in the expansion, just multiply these two terms together, 2x times 3, that's 6x, and then always double that. So you got to remember to multiply these together and then think times 2. And then you square this last term in the parentheses, 3 squared is 9. Okay, follow that same process. We'll square this binomial, 4x squared minus 20x, 2x times negative 5 times 2, and then you square the last term, you get plus 25. And then once more, first term squared, then you do first times second times 2, it's 14x, and then the last term squared. All right, so now it's cleanup time. The left side I'm just going to repeat. Just going to bring it down, and then I'm going to combine like terms on the right. So 4 plus 1x squared is 5x squared. And negative 20x plus 14x is negative 6x. And 25 plus 49 is 74. Okay, and putting all the terms from the left side to the right side so that this can equal 0, I'm going to subtract 4x squared. I'm going to subtract 12x. And I'm going to subtract 9. 65. Okay, so fortunately there is a way to factor this trinomial. Both binomials will be minus. The factors of 65 that add up to negative 18 are negative 13 and negative 5. So now we use the factoring in order to solve. I get two solutions. X is 13 and X is 5. So the answer to the first question is, how many right triangles have a hypotenuse that measures the following? That's going to be 2. Because these represent the dimensions for two different triangles. Two triangles. So that will answer question number 1. Now, what are the dimensions of the triangles? Well, to find the dimensions, just take each of these one at a time and plug them in for x. Okay, now I'll trust you to be able to do that to finish that off. So let's just get an idea. One of the triangles will have a hypotenuse of 2 times 13, which is 26, plus 3 is 29. And the other leg, I'll just say leg 1, will be 2 times 13, which is 26, minus 5, which is 21. And then leg 2 will be 13 plus 7, which is 20. And then to find the dimensions of the other triangle, you just go through and you replace x with 5, and you do the same thing. Okay, so that's pretty much the conclusion to problem number 91. Let's do number 93. The area of an opening of a rectangular window is 143 square feet. So I'm going to draw a rectangle representing our window. Clean it up a little bit. Okay, and we're told that the length this way is to be 2 feet more than the width. So if I let W represent the width, then if the length is 2 feet more, then it should be W plus 2. And we got to remember how to find the area of a rectangle. So for a rectangle, area is length times width. So I'm going to take my representatives for length and width and length, and I'm going to set it up to find the area. Okay, so area is W times W plus 2. We're told, however, that the area is 143 square feet, so I can replace A with 143. Okay, so now I'm going to solve this, and so I need to distribute on this right side, W squared plus 2W. Set it equal to 0 so I can solve it. W squared plus 2W minus 143. It does factor this trinomial, this quadratic trinomial factors as such. You can use positive 13 times negative 11. That will give you, that's the product of those two is negative 143, and the sum of those two would be positive 2. So I get two solutions. However, one of these does not make any sense. Obviously, negative measurements don't make any sense. So even though I got a solution negative 13, I'm going to toss this one out, and I'm going to go with the reasonable solution, which is 11. So the dimensions are the width is 11 feet, and the length should be 2 feet more, so it's 13 feet. And that is my answer for number 93. Okay, here we have this constructing a box problem. We have an open box to be constructed from a piece of sheet metal. And it says we're going to do this, we're going to construct this box by removing a square of side 9 centimeters from each corner. So let's just picture what that looks like. I'm removing a square. Pretend those are straight. And basically 9 centimeters from each corner. So we're just going to cut out these corners, essentially. Let's go ahead and label all these. Okay, so if the box is to hold 144 cubic centimeters, so that refers to volume. We're looking for how much of a certain quantity, whatever that is, water or whatever, it's got to be able to hold 144 cubic centimeters, and that's what volume refers to. So remember, we find the volume by doing length times width times height. Okay, so we got to figure out then how to represent length and width, and then we need to reason through, well, what would the height be? Okay, so let's think about this. It's a square, so length and width will be the same. If this entire side is called x, and I'm essentially cutting off part of that side, that part of the square, the corner that's being removed, then I can represent, if this is width, we'll call this width, then width is going to be x minus 18. If the whole side is called x, then we're starting with x and we're removing 18 centimeters. Okay, and that's going to be the same thing for the length. Okay, since it's a square, then length and width are the same. Now the height, we have to pay attention. We're going to be cutting off these corners and turning up the edges. So when these edges are turned up, remember this is a square of 9 inches. When these edges are turned up, instead of being a flat surface, the edges turned up will be 9 centimeters. All right, so instead of x here, I'm going to say 9. All these multiplied together, length times width times height, should equal the volume, and we're told that the volume is 144 cubic centimeters. Okay, so another way of representing this, I'll just write it like this. Since it's x minus 18 times itself, we could write this equation like this. 9 times x minus 18 quantity squared is equal to 144. And so now we'll solve for x. We'll first divide by 9 on both sides. And 144 divided by 9, I believe, is 16. Yes. And now we can do the square root of both sides. X minus 18 equals plus minus 4. And now we're going to add 18 to both sides. And we're going to get two solutions again, sort of like we did in the previous problem, but one of them is not going to be a reasonable solution. So 18 plus 4 is 22, and 18 minus 4 is 14. Well, let's take the 14 answer. Just think about this. If I'm cutting off a total of 18 centimeters from the side, there's no way that this side could have started off being 14 centimeters. So that's not reasonable. So the only reasonable answer of these two is the 22 centimeters. Okay, so the dimensions of the sheet metal, these should be 22 centimeters for each side. Okay, 22 by 22, or the sides should equal 22. Let's put it like this. Sides will be 22 centimeters each. Okay, that takes care of that problem. You got a problem very much like it. And then this is going to be our last example. A ball is thrown vertically upward from the top of a building 96 feet tall, and the initial velocity is 80 feet per second. The distance in feet is given by this function, where s is the distance in feet and t is the time in seconds after the ball is thrown. How many seconds after it's thrown will the ball be above the ground is essentially what this is going to tell us. So let's take letter A. After how many seconds, or in other words, what is t when the ball strikes the ground? Well, if s represents distance from the ground in feet, and we're told that it does, when the ball strikes the ground, it's 0 feet above ground. So I can replace s with 0 and solve for t, and I will know exactly how many seconds it takes for the ball to hit the ground. Okay, you might want to turn this around, Possibly, it really doesn't matter if you want to make it standard form. Okay, so remember, you can solve quadratics in a number of ways. If you wanted to, you could use the quadratic formula. As it turns out, this does factor, and I'm going to factor out negative 16 as a GCF to begin with. And if I factor out negative 16, I get t squared minus 5t minus 6. Negative 16 goes into 80 negative 5 times. Negative 16 goes into 96 negative 6 times. So we'll continue factoring. And the factors of negative 6 that add up to negative 5 are minus 6 and plus 1. So I get t is 6. I get t is negative 1. Remember, t represents an amount of time in seconds. And obviously we can't have negative time. So once again, we have an answer that does not make sense. It's not reasonable. So the only good answer of these two is 6. So the answer for letter A, after how many seconds does the ball strike the ground? 6 seconds. Okay, letter B, after how many seconds will the ball pass the top of the building on the way down? So maybe we can take a look at a picture. Here's my building. Okay, and the building is 96 feet tall. Okay, so here we are, we're throwing from this point, we're already 96 feet above the ground when we throw the ball. Okay, we throw the ball, then it comes obviously back down. So we want to know, when does it pass the top of the building on its way down? Okay, so it's going to reach its highest point, and then obviously it's going to come back down. So we can think of it this way. The ball is 96 feet above the ground when it's thrown. Okay, so instead of saying let it be 0 when we want to know when it strikes ground, this time we're going to let the equation equal 96. Okay, so I'll just turn that around. This is part B. Negative 16t squared plus 80t plus 96 equals 96. Okay, so when we solve, we subtract 96 from both sides. That equals 0. We can factor out negative 16 again. Actually, negative 16t this time, because we have t in common. And that's going to make t minus 5. And we set both of our factors equal to 0, and we get two solutions. T is 0, and t is 5. Okay, so this tells us two things. The ball is already 96 feet above ground when there are no seconds, when the ball is no seconds in the air. And that makes sense because we're throwing it from the top of a 96-foot building. So no time has passed. The ball is still 96 feet in the air. Okay, when it reaches its highest point and starts to come back down, according to our answer here, that takes 5 seconds. It's going to take 5 seconds for it to reach its apex and then come back down and pass the top of the building on the way down. So the answer to part B is 5 seconds. All right, and so that concludes the notes portion. I hope that seeing these examples and working through them will give you an opportunity to successfully complete the homework problems. So if you have any questions, let me know.